Alrighty, so we're reading. This is from the 2023 exam, question 9. I've just told the class that I probably can't write a question this good, and so it's more that we're doing it together as a class. I wouldn't expect you to be able to do it by yourself, and it's probably not a great exam test question because it's, yeah. But anyway, it's good to go through together. All right, what are we thinking? I'll give you a moment to read it. Hitting me square in the face with this one. What's the key bit? Okay, the 5 roots, but I'm also really making sure I'm looking at that bit there because I'm straight away thinking nth roots of unity. Okay, so if you haven't got on your help sheet, your little thing, do we remember the nth roots of unity? So if we've got z to the n equals 1, then we've got z equals 1, w to the 1, w to the 2, w3, all the way up to wn take 1, where w is cis, is it 2 pi on n? Yeah? Now, obviously, if you have to go, oh, what was that again, and go and look it up on your help sheet, if you're in that mode where you're going, oh, it's okay, I've written it down, you're wasting time. These should be things that you're flying through, all right? So when it now comes, and it gives you the clue here, use de Moivre's theorem, to write down your roots, we should be easily able to go and write these down pretty quickly. So can you do that for me, please? What would be my roots?
1.
Yeah, well done. First in gets the easiest answer. Good job. Right, 1, and then we're going to have cis 2 pi on 5. Excellent. But then it becomes cis 2 pi on 5, but it is to the 2, which then becomes cis 4 pi on 5. All good. It's between our pi and minus pi. Keep on going. I'm a bit tired of bending and writing, so I'm going to be a little bit sneaky, and then, actually no, I won't. Do good behaviour. Model good working. 3, cis 6 pi on 5, and I guess the bit that I'm asking for, do we leave it like that? No, because it's more than pi, so take 2. So 5, 10, so that's going to be minus 4 pi on 5. Speak now, forever hold your peace if you're not sure why. Quite nice, and just a reminder that when you are plotting, if they were asking you to draw those, draw it on an Argand diagram. They've actually done it for you, but what do we know about these? They are evenly spaced. You have seen before, some of them might be drawing them without the circle, because they're not only evenly spaced, but they're also equal in length. Okay, same modulus. So make sure that you've got that very clear if you are asked to draw them. Looking at the previous test, I think every time you are asked to draw them on an Argand diagram, so I think you can probably guess. My dilemma is, what power do I give you? I'm going to assess you on the nth roots of unity. Is it 3? Is it 4? Is it 5? Oh, I don't know. I might go lucky 7. Who knows? Same thing over and over again. Starting with, it's a bunch of modulus done together. So one of the 2 things I like about this question was the first was, how do we start? So I'm looking at the less than or equal to bit there, and part of me has got that triangle inequality part in my mind because we were playing around with that. The other bit is I'm going, what on earth? I don't know. So I don't know what to do. I'm at least going to, yeah, when in doubt, sub. So we've got z squared plus z plus 1 plus 1 over z plus 1 over z squared modulus. Now, what does that equal? Yeah, this is actually, if we can do that, this is going to be less than or equal to, we can separate each one of these. Now, I could do it as, that's going to be z squared plus, plus 1 over z plus 1 over z squared. Right, so that bit there is 1, if that was 1 length. And then the other one, I could keep doing that with the triangle inequality. then I can separate this one and 1. So I basically can say, using the triangle inequality, I can separate each one of these. Oops, missed the 1. Triangle inequality. Remembering, if you use the triangle inequality, you have to say that you have. I mean, try and make sure that you're fighting for every mark, at least substitute. You might then have seen, Josh, you were saying you were using the modulus property where you could separate. You might not have hooked up with the triangle inequality, but at least you've done something. You're trying to at least get as many marks as you possibly can. But yeah, that one was unique. Well, they are the roots of unity, because remember, if you just keep going around and around, it repeats. So you could have started with, yeah, they just overlap each other. So if I times through every single one of these by z squared, I would get z to the 4, z3, z squared, whatever. I basically get all of those roots. They're just in a different order. We okay with that? Part C, yes, I'm getting to it. But yeah, for what value of z will the b equal to 5? Well, it would have to be 1 plus 1 plus 1 plus 1. Yeah, thanks, Josh. Okay. C. C, senor. Sorry, it's fuzzy. Okay, what's our motto? Do something. Yep, do something, sub. So we want to show that this equals this. Now, most of the time we say 90% of the time it should be left-hand side equals. Start with the left-hand side, show the right. But not in this case. This is a little bit funky. So for this one, we're going to start with the right-hand side, show that it equals. Because the only option for us to go from left to right would be we have to try and factorize, and that's just going to be way too crazy. So right-hand side, we've got z squared, z take 1. What is our f of z? Good Lord. Little tip. Well, I'll ask you, how would you expand this? Who would give up on it and go, that looks disgusting? Good chap. Is? I'd probably look at that and go, oh my God, no. You don't always have to work from left to right in this. So you could absolutely times this through. I'm actually going to keep that z take 1, and I'm going to times this whole thing through by z squared. I just think that would make my life easier. You don't have to listen to me. You could expand that, but do your thing, see what happens. To wait for me. So, yep, I'm not doing it all, but I just now times everything through here by z, then times by -1, and hopefully, bingo, bango, bob, we get that. Hence, got to love those hence questions. Hence, list the 4 roots of f of z in polar form. Hence, list the 4 roots. I have to stop. Do you think we should at least look at getting f of z? Rearrange, that's right. Like we go, well, this, how am I meant to get the roots from here? That's no good. But when we've got this bit and it's got the hence, then I'm looking here and I go, oh, well, who knows? I don't know what's going to happen. But if I rearrange and go f of z equals z to the 5 minus 1 all over z squared, z take 1, we at least go, hey, the roots appear when you are making the function equal to 0. Now we know that this whole thing will be 0 when z to the 5 take 1 equals 0. Isn't that our whole roots of? One problem. How many roots did we have? 5. Let's just read that question again. 4. Well done, boys. Right, so the denominator, finish off your statement.
Yeah, so the denominator can't equal 1, so 1 is not going to be a good solution.
Oh, sorry, you can't hear that on the thingy. We'll come around to mystery student. Say that again.
So x take 1 is on the denominator, so 1 can't be a solution.
Correct. So we go back to the solutions that we had, and therefore we can say that they would be cis 2 pi on 5, cis minus 2 pi on 5, and cis 4 pi on 5, and cis minus 4 pi on 5. If I'm, wanting to get that A plus, I'm writing down there z can't be equal to 1. Okay? Z cannot be equal to 1. Go for gold. Does that make sense? But again, I wouldn't have seen that, wouldn't have thought to do it if we hadn't rearranged. If you're just staring at it, no good. Do something. So we're looking at this. A little bit worried. We said, do we know what f of z is? Look at it, write it down, and then it's saying use z equals cis theta. So what will you do?
So I'd replace the whole thing with cis theta.
Sub it, man, sub. Do it. See what happens. Right, it's telling them, replace z with cis theta. Now, you didn't have to do this. You could have kept it as 1 over cis theta. You would have got to the same bit anyway. So then I've got cis. When I've got cis theta squared, what is that? Cis 2 theta plus cis theta plus 1 plus cis minus theta, and then cis minus 2 theta. And now we go, oh, good stuff. How does that prove that it is real? It would be really nice if I could just cancel out the cis 2 theta with the cis minus theta. Am I allowed to do that? I am not. Josh has got an idea before he tells us. Is there anything else, if you're desperate, that you could do? Indy has an idea?
Please take the microphone.
Okay, doesn't want to talk on the microphone. Yep. What would you do? I'll stand over here. The other form for cis theta, fantastic. We know that cis theta is actually cos theta plus I sine theta. And there's another little tip, real. Well, where is it imaginary? Right, so cos theta plus I sine, it's pulling that. Let's hopefully, what are we hoping to do? Cancel out imaginary stuff. So, I sine 2 theta. I'm going to run out of room. I'm possibly running out of room. I'm going to be a little bit naughty at the moment because I'm going to write just this is cos theta minus I sine theta plus cos 2 theta minus I sine 2 theta. That is okay as long as I do one thing. Yeah, I write the little cos negative theta equals cos theta and sine negative theta equals negative sine theta. Okay? And hopefully, what happens? The imaginaries say good night. And so we're left with just the real. That will go, oh, that's actually not too bad. It's pleasant. Any takers for what we're going to do with part 2? Oh, Tom, quickly with his hand up. Just let everyone know. Wait. Just get everyone have a little bit of a think. So just to finish off, it's only worth 1 mark as well. How do we turn this into this? Tom, what is, without saying it, what would be the hint that you would give people if they were stuck? Formula sheet. Do we need another little hint? One more? One more? Do we need one more hint? We've got some people shaking their heads and some are not saying anything. So that might mean some people need one little more hint. Cos 2 theta, could you replace it with anything? So have a look at your formula sheet. You should be able to do that. And I think we'll leave it there because that's a lot of me blabbing. If you go back, you've got lots of revision questions. If you've got questions for me that you've pulled up, I plan to have Thursday's lesson. It's just you ask me any questions that you have, your time. I won't interrupt you. You might want to go back and have a look at question, was it 4? 3. Once again, it's another thing about the rotation and angles argument. And I thought that was a very pleasant question.